Hey, welcome to this episode of JAKTALK. My name is Jeff Kinsberg. I am the founder and visionary behind JAKTOOL. We are a precision product development company, and we love to partner with technologists and engineers and help bring their ideas to life and transition them to scale. Today in the studio, we are joined again with Dr. Jim Reuther. Jim is a subject matter expert and consultant to JAKTOOL. In a nutshell, flame wizard. Welcome back, Jim.
Well, thank you for having me back. It's, again, a humbling experience to be here and being able to share information with you and ideas in terms of divergent thinking.
Drones. That's what we're going to talk about, but not where everyone thinks. Let's dig into, so with drones are toys, drones are weapons, drones are useful tools. There's a changing, there's been a huge acceleration of the usage and deployment of them in different theaters around the world in combat situations. There's reports, there's video of the battlefields in Ukraine strewn with fiber optic cables. There's other theaters we're talking about, but that's very common right now, and the threats are evolving, but not where everyone thinks is. So today's discussion is what is life for a drone after it's used, and where does all this stuff go, and how do we get a better use out of it? Forward thinking. What are your thoughts? What do we do with all of, I have my cell phone. There's the bin in some stores, we recycle. My town has electronics recycling. There's a lot of materials, technology that can be recycled or upcycled to try to get ahead of this industry. What do you think we're going to do with all this stuff?
Well, that's the central question of today. The last times I was here, I was dealing with problem solving. Today, I'd like to talk about identifying a problem and essentially creating awareness of a problem that's coming down the highway or coming down from the sky that needs to be addressed. You touched on a couple of items that have to be, after they're used, they're discarded. Cell phones can't walk or fly, so they're not drones. So they're going to be, they would like to be recycled and get the materials from them. There are resources. A lot of critical materials went into making them, and they were being thrown away. Now people are thinking, what's the return on investment? And that's going to be the key on this same problem. We're going to talk about what it takes to recover the materials that you put into a product. So it's a different kind of thing. It's problem identification. Now, what came to mind to me is the genesis for this was first words and popularity contests. Back in the day, there was a movie called The Graduate. And when he graduated, he was given some advice by a friend. And he said one word, and he said, plastics. It turns out that that's going to be the word of the day again with recycling a lot of these materials. Then came along another one, nano. And everybody wanted to do nano. Well, today it's drones are us. And everybody wants to make them. They have short lifespans, and what happens after them? Now, the light bulb came on in my head watching a drone display. Thousands of drones illuminating a Statue of Liberty.
Light show, okay.
A light show, mini drone. So the light bulb came on. I like to do puns. Mm-hmm. And as I was looking at them, and I said, where did they go after the show? Did they fly home? What do they do with them? Did they all fly back to different positions and they recharge their batteries? And then finally I asked, what happens when they want to retire from showtime? Mm-hmm. And then I said, what happens when they're dead? And it turns out that for the moment, they're being discarded. They're a disposable technology, just like cell phones. I mean, they're valuable commodities. And that's the way I want people to look at it. You put a lot of effort to put these materials in. What is it worth to recover them? Mm-hmm. And as we'll talk, some of the materials on these are in short supply, and we rely on them from foreign sources. So what would happen if we were to cut off from some of these sources? And of course, we know that it already has been done by China in rare earth elements and like. So there's an emphasis here on not throwing them away. They're not disposable technologies. And the question is what do you do next? What are the challenges to it? And here's the best part. When we discussed this a couple of months ago to do this project, we did a little bit of research. We came up with some information about where how many there are. Well, there's 7 billion phones on the planet. There's 8 billion people. There's almost one per person. Drones are now getting into the millions. What happens to them all? They just want to dispose of them. So I went to, of course, the internet and did some searching, and I did use AI to find out some information. And guess what? I got very little. I was surprised. I searched different terms. I asked different questions.
You were asking it, where do they go?
What happens to them? Recycling. I was looking for information. It was scarce. That surprised me. Now, it's what I would get is if your drone, dies and you can take it to a local shop and they'll, recharge it and repair it. But there was no open source information on what people are doing. The next question is why don't we know about this? Now, I know that some of these technologies are very proprietary, so they're not talking about it, but it's not very visible. The only tangible number that I got was they typically spend 10 to 15% of their budget on recycling. But this is U.S. centric, so it's a little bit skewed. If you look to Europe and the Scandinavian countries, they're the vanguards of recycling drones. So, in fact, some of the papers that came out of that said that this is a point of emphasis and that the world should be looking at it, because there's going to be a tipping point because of all the applications. And
so to this tipping point, we're trying to get ahead of this, right?
Exactly.
And give some leadership here, some thought leadership, but it creeps slowly to the tipping point. So I think to myself, a drone sounds like a radio control plane, helicopter, car. Most people have had one at some point in time. I still have the few that I had from childhood. And a lot of the other engineering nerds out there are attached to their gizmos from youth. But the difference is that we're not, this is going to become a tool in everyday life, right? And it's not one or two per person. This is going to be consumed, this is going to be, think about, drone delivery for food or products, right? This is going to start to become part of the commercial distribution, as opposed to, whether it's commercial distribution or military uses or, other, the quantities are going to go.
Exactly. Right? They're going to go through the roof. So right now we think the information is they go to landfills. Now here's the irony. So you mentioned the multiple sources, food delivery, package delivery. Some of the popular tasks that they're given drone is for real estate, for homes and the like. And then as I was searching deeper, real estate came to inventorying landfills for different products to see where they are, to keep track of things. And then finally, the one that cemented this was they're used to survey graves. So yes, grave sites and getting aerial photographs so that you can coordinate and find things. So I'm looking, from cradle to grave, and I'm saying, where do drones go? I mean, they're going to the grave, they're going to landfills. I mean, so these are the key words. There's a lot there. The information is scarce. And again, the question is what are we talking about? What is a drone? And there are many types, and they have sensor packages on them that have electronics in them. They have cameras. We're talking about the bulk materials. What happens to the airframes, the skeletons that are different materials? They're polymers. They're plastics. So it was first full circle when I thought of The Graduate and plastics, and I'm saying, well, we're trying to get rid of plastics now. So we're back in the game. So there are technologies for recovering a lot of these ingredients. they're expensive. They're time consuming. The number one challenge is logistics. Where do you put these? And I'm sure that a lot of companies pay to have someone take this away and make it disappear in a landfill. And talking to the EPA administrators to a couple of states in the Midwest, they're trying to get the drones to be segregated in the landfills so that they can find them, they can resource and recover them.
Again, what is a drone? I think of, a drone could be a full-size airborne platform that's unmanned, and then you see drones the size of insects.
Exactly.
There's going to be a proliferation that we're focusing on of one particular scale, right? So if we had a billion drones the size of an ant, so what, right? It goes in the corner of the dumpster, right? Mm-hmm. If you have a manned, an airborne platform that's the size of a manned airborne platform, that's going to be decommissioned, by hand because of just the nature of the volume of it. So there's a certain size where I think we're both focusing this discussion on.
We have biased our discussion and our points to certain categories already. It's a subliminal bias, as I like to say that word. But that's the thing is what is a drone? What's their population? How could you standardize this? How could you do this? One of the ways they do cell phones, they just put them together, take an item out of it that's dangerous and crush them all, and then chemically treat them, mechanically treat them, and the like. That's what they're doing. For cell phones, we have a lot of technologies that have done this kind of recycling already. It's the extension to this process. So for drones, I like to make a joke that they could fly home. Mm-hmm. They could fly to a designated site to be recycled. I mean, they're not like a cell phone. That cell phone can't walk or fly, but you can walk or fly or move something to a designated site. Inventory, what are they? When I came here, I experienced for the first time that my rental car is going to be photographed as I drove through a sensor curtain for pictures to make sure of damage. So they could fly through sensors. They could be tagged. You could so that you could find out what's on board, what critical materials they have. So, I mean, there's lots of the technologies are all around. The fact that we have AI and a lot of machine learning, you could do a lot of information to find out what the problem is so that you can scope it. That's the problem. You have to, we're not talking about every drone. We're talking about a class of drones that it would be cost favorable to recycle the materials in them.
Mm-hmm. So how big of a red flag is this?
It's a freight train coming our way. Landfills are now screaming about where they're going to put all of these skeletons. There are sites that are full of these materials. You mentioned it. It's the scale that's going to hit us. No one's worrying about it now. This is the point that you make at the beginning. JAKTOOL's philosophy is to solve, what matters most, but to look over the horizon of what's coming next. There are warning signs that there's going to be a lot of things to deal with, and it's a lot of resources that are going to be thrown away. Now, there's a critical mass to this that's coming, that's going to say, now we have to do something. This is why we have the Superfund sites. They just dump things, and now all of a sudden we have to go back and clean them up. This is really looking into the future and seeing something that's real. And there are some very technical papers written from the European Union about this problem. It's coming in the future. And our hope is that what JAKTOOL and its company can do to be on the leading edge, to be the first in to call this a problem, to try to get interest, get awareness, get advocacy, so that we can be on the leading edge for this. Again, it's a notional thing. Some people will say, well, we're not worrying about it right now. Okay, but I guarantee you that there's going to be a crisis moment in the future with these materials, especially if these materials are critical. There has to be a critical mass. There has to be a critical mass of critical materials. Cobalt and some of those materials that are from the Congo, licensed by the Chinese. different materials, aluminum, titanium. When is it going to become that these materials are critical enough that we have to do something about it? I spent a lot of time on the critical materials task force, and we're behind the problem. I'm trying to be ahead of the problem. Mm-hmm. I'm trying to be on the leading edge of this, saying this is coming along. And when we see what happens, I don't want to say, I told you so, but I'd like to know what we can do now to start working the problem. This is a long-term problem to solve, but I think the earlier we get in, the better we'll be.
So I'm thinking about the different things I'm used to with recycling, right? As I mentioned, cell phones, electronics, I take to municipal waste. It goes in a Connex, throw it in, and they take it somewhere. I assume they grind it all up and they separate the gold and any other precious metals from the plastic. The plastic probably turns into landfill, and they capture what they can through some chemical process. Hmm. A couple of, not glamorous, 2 weeks ago, I installed a dishwasher, and I took the old one because I'm cheap, because I didn't want to spend the $50, and I took it to the scrapyard. They gave me $6 for it. There was other things on the truck, but I take it, I throw it off the back of the truck, and it's predominantly metal, which is why the scrapyard likes it. There's plastic, but it gets crunched up. The plastic gets separated from the metal, and metal gets recycled. So those are, the dishwasher is essentially it doesn't have a lot of precious materials in it. Or maybe it does. I don't know. The dishwasher doesn't seem to me like it's got a lot of precious materials or technology that should be upcycled. Unless you're MacGyver. So what are the materials? What do you have a vision of how this waste stream works?
Well, I think they go for the high value materials first. And of course, they're in the sensors and the cameras and the electronics. One of the things that is JAKTOOL's specialty is engineered solutions. Mm-hmm. And what has to be advocated is that they should start designing drones for disassembly. Mm-hmm. There's ways to do this. There's modularization. They should think about what they can do to recover their materials themselves. They know now there's a lot of proprietary technology and designs and the like, but the idea if they could start their own process by doing some of that. Now that would make manufacturing and production more standardized. It's quite standardized now, but design it for the afterlife. In other words, so that it isn't obsolete and worthless. It essentially, you're building value into your product by having it so that it could be disassembled, and you do know what's on it, and be able to recover it. So they have to start thinking this way for the end, and instead of passing it off to somebody else.
So maybe fortunate for those who can see over the horizon, unfortunate for those who can't. I guess maybe that's kind of part of our competitive advantage is helping see that. People don't, there is no pain for this problem yet.
Exactly.
At least it hasn't surfaced. At the time of this taping in a week is an industry day for the interface that's been standardized by the Army between the drone and the munition. And it's called a CLIC. There's a CLIC industry day. That is currently the pain, right? How do we integrate munitions to drones and standardize that interface similar to, firearms enthusiasts with a Picatinny rail, right? So that's where we're at, right? We're designing interfaces. So we have munitions, we have drones. We're focused on the interface. It hasn't arisen yet. Hey, what do we do at the end of the life cycle to separate all of this stuff, right? So whose problem is this?
Well, the pain is going to come from the Environmental Protection Agency, because they have task force of what to do with the drone landfill problem and the like. They have, quote, recycling centers where they stage materials to be recycled. Mm-hmm. And right now, They're the leading cause of lithium-ion battery fires on the planet. They're prolific. These areas are remote and isolated, so it's okay for things to burn, but they set fire to other things. So safety is an issue, but the Environmental Protection Agency if they come down with regulations that say you do have to do something better with this, that's going to be the motivating, and it depends upon how strong the regulations are. The risk is if they do make regulations, the question will be is whether or not paying the fines for not complying are going to be less than the cost of complying. So it's a problem. Again, we're going to get ourselves into a Superfund source with landfills full of drones instead of other materials.
So I'm looking at some notes here that we're jumping around here. Does the DoD have formal programs for disposing of these materials?
Yes, they do. They have several of them, and we've listed them. But the question are drones on their list? That's a question. I'm asking that out loud. We'll find out. But are they looking at that, or are they looking at other materials? They've got a lot to do already. I spent 8 years in a bunker in my career demilitarizing rockets and mortars with chemical agents in them. It was the DMIL program. Mm-hmm. It was for Pueblo, Colorado, and Richmond, Kentucky. And the program was done, and it was successful. We got rid of all these munitions. But then DMIL becomes a non-existent word. If you look at budgets in my career, one of the reasons why we got out of the business is there was no emphasis. There's no need to DMIL anymore. Mm-hmm. We have to DMIL. There's a lot of scrap from testing where you shoot down drones. What happens to all those? They're just disposed of. They're just the broken bodies, little gnats that are crushed. Mm-hmm. So it's hard. We're not crying wolf. This is a real problem. You can see the proliferation of drones, and you can see the mass of materials and the effort. So the earlier that you can get in, the better you're going to be off in the future. So,
Jim, you've got tremendous experience with energetics and explosives, and touching on demilling and how do you safely take munitions, whether they're at a depot and they need to be demilled, or whether it's an IED in the field and it needs to be rendered safe. I don't think of demil as anything sexy, right? But it's a necessary thing. And I working on it's much, when we're going into the design processes for the products and systems that we're working on, we usually don't get requirements for materials recycling. What does the waste stream look like? It's a good question. I don't know why. Maybe we should start asking that question to our customers for the requirements analysis phase, but our customers are just thrilled to get something that works. Right? Mm-hmm. Adding more requirements, more time, more money, we'll punt this to another phase of the project, right? When we get traction. And look, there's handoffs and projects between program managers and beyond JAKTOOL, and you lose the vision over the horizon of some of this stuff. So, when I talk to munition designers in the Army, I don't know if anyone is thinking really top of mind about what does end of life look like. I feel like that's where the DMIL folks and the munition designers do the finger pointing, and there's that trade space of, do you want functionality or do you want to be able to DMIL it cheaper? What are your lessons learned or things you've observed that we could kind of share with the design community, but not from the munitions perspective, but how do you design this upcycling mentality into new systems?
Well, one of the things is better inventorying of what the system is. It's a drone. What's on it? What are its components? Could you tag them? Could you inventory them more? Because the biggest problem we had in DMIL is what exactly is in front of us when we're doing this. Mm-hmm. We had surprises. As I recounted, we had some things inside these weapon systems that we never thought of would be there, and different parts, the different configurations, different materials, different explosives, different seals. I mean, there was no regularity in it, and that raises the costs up tremendously. So, inventorying and knowing what you have is the first thing.
So that's a great idea, because the drones I'm thinking about these are consumer grade drones, right? And how great would it be if there was a QR code on it that the recycler scans? It takes them to an index online of this system has these components. This is what's valuable in it, right? And then they can decide how it gets recycled. So that, you talked earlier about EPA and coming in. Who would own that? Is there the drone recycling board? But something as simple as just organization, just a top level bill of materials of what's in it, right, would be so useful, almost for any product. But so that's a great idea.
It has value, and what bothers me the most is we now have the tools. We didn't have AI. We didn't have QR codes. I mean, make the joke. My daughter makes the joke that, she said, "Dad, do you know how to spell QR code?" And I said, "I'm old school, but you can do these things, and they're not a major investment." Back in the day, we were logging our munitions with paper and pencil, and then computerizing them and doing, evaluations. But now this can be done. I mean, you can put barcodes or QR codes. You can tag them. You just better know what you're dealing with, so that when you do wind up with it, you can tell someone what they're going to take on. And it can be done. That's the thing that's right now, is that we have the tools to start this process, the scanners and things like that, robotics, an automation of the process. If you could have your design package and you could say, how could you set up a robotic system that could systematically take a drone apart, pull its legs off,
right,
like a crab or something, or so that the tools are there to start thinking about them, and they're not that expensive to do this. So the first step is knowing what you have. What is a drone? What's on it? What are the critical materials? You're going to get them. People are going to go for the high price things, the cobalts and the metals. And if there's any rare earths, electronics, they're going to get after the electronics just so that nobody else gets them. I mean, there's the information there, but it's the rest of it, the rest of the parts, grinding them up. You could grind up the polymers and the plastics and the carbon fibers, matrices, and put them as aggregates. You could put them in cements. You could put them in. One of the ideas was to put these materials into mounds of earth, dirt, to make them structures, essentially the same as you do, road structures to make, as fillers, to make them more robust. You could put them in to have earthen dams that might be stronger, lattices. Mm-hmm. Again, I don't want to get too pie in the sky. That's a deliberate pun. It's a pie in the sky. It's got some value. Is to you could put them in the skeletons and the airframes into reefs as barriers. They're essentially allowed it to break waves and things like that, provided that they don't contaminate anything. And that's the key. Is what on board would give you heartburn besides the obvious components, getting the materials. What would be an unintended consequence of doing anything with these materials? Mm-hmm. But there's an infinite supply of these materials. The question is you want to know what's in them, and you know where they are, and then what you do next is you mine them, because you now know now you have a resource and you can take care of it in that way.
Yeah, it's interesting. You said mine, and we touch on space and following the industry. There's going to be there's going to be a competition for resources, off Earth, right? It's not a matter of if, but when, because we will run out of resources on the planet at some point. And the return on investment when you think about how to rack and stack priorities of, does it make more sense to go mine other celestial bodies, or does it make more sense to, find ways to upcycle what you got? That's beyond this discussion, but that like, when you think of the cost to go, mine Mars versus put QR codes on things and take them apart and track the resources, there's a lot to that.
That's brilliant. That's JAKTOOL brilliance, that you're thinking of the larger problem. You're looking at alternatives. That's what's called divergent thinking, is that you're asking questions from the outside in different ways and looking at different opportunities and advantages and disadvantages. And that's the vision. That's the leadership. That's the thought leadership that needs to be done. As I mentioned, other countries are doing this. Other countries are giving this priority. Ask the question why and how are they doing it? They recognize the need for that. Now, they have different circumstances, of course, different countries than from the U.S., but they are working the problem, and so they're leading the cause, and we have to learn from them and see how it applies to domestic use, because it's going to happen, and it's a business.
Mm-hmm.
It's a business. There's going to be opportunities. I can see lots of opportunities for some of the projects that JAKTOOL has told me about. For example, the battery removal, the battery cutter. I mean, there's a problem where that solved the problem of taking a battery out of an object that wasn't hard to get out. I mean, and that
it was never designed for it, and it took us better part of a year to automatically recycle a battery.
That's right,
in mass.
So there's a mini example of a non-drone situation. Imagine how many of these devices do you think are going to be made? I mean, that you solve the problem for? Hundreds,
tens of thousands.
Tens of thousands. Okay, well, we're talking tens of millions. We're talking about hundreds of millions. So magnitude, magnify the problem. That's the whole idea. Is we're stuck with what we have. Can you start turning the tide to get something that's going to be easier to do now? As I said, there's a tipping point. We've got a large mass, but this curve is going to go vertical in the future, and people are going to say, "Whoops, we want to catch this rate of increase of production." I mean, the applications are astonishing. The Chinese are using drones to spray crops. It's going to get out of control.
Mm-hmm.
So this is the inside track. This is a peek at the future. There's opportunities there. We need to make sure. The number one thing for this podcast is to be aware that this problem is, and to have an advocate speaking out about it. We are, because it has potential for value. It's not right away. It's not going to have immediate value. I mean, because this is the long haul, but the longer we wait, the more expensive it's going to be to take care of the problem. We know this from past experience in several environmental crises in the past.
Yeah. So I guess to wrap up on this thought is, as you're talking and we're going through this, the crab and the QR code are just like stuck with me. So, I've been a part of senior design projects with universities for, the better part of 20 years. And, it's incredible what the students can do with a Raspberry Pi and Arduino and, off the shelf robotics to solve problems. What I challenge everyone out there to is to get ahead of this, right? So if for any students out there that are going into that capstone course with their school, I challenge you not to design the next drone. Do something simple and get very far ahead of the problem. Something as simple as taking an off-the-shelf drone, putting a QR code on it, and saying, here's all the things we want to recycle. 2 drones, A and B, right? And then you have a robotic arm, right? Scan the QR, robotic arm scans it, right, pulls up a library and it systematically picks apart the drone. It could be in Legos, right? Puts it in bins, right? That's the proof of principle for this, right? And then what comes out of that is what are the limits of what are the preferences or limits of disassembly? And you don't know what that is till you know what the disassembly process starts to evolve to, and then take those signals and put them back into the design of the drone. You know, we would be getting ahead of ourselves to say this is how it should be designed without knowing the decommissioning process. But until somebody's thinking about the decommissioning process, it's just you know, in the ether. These are thoughts with no traction.
And that's exactly the catalyst that's needed to get this underway, is to do those proof of concepts, trade space studies. There's things, machine learning. Give it something to learn. Give it something to know. And then let artificial intelligence work with the numbers and come up with different scenarios. All of these tools are available for this. You know, where do drones go when they die? We hope they go into other bodies, other uses, because there is a finite, as you mentioned, there is a finite supply, and we don't want to run out. It's just like any commodity and any, for example, fuels and petroleum. You know, everybody was concerned years ago that there were books written on the last drop of oil. Well, all of a sudden, people started finding oil all around the world. This is the last. We're not at the last drop of materials, but we don't want to be there.
Mm-hmm. It's going to be very uncomfortable.
Yep.
It's going to.
Now the question is it going to be in my lifetime as a senior citizen? But I'd like to see it start. Mm-hmm. I'd like to see something done to establish how viable, both technologically, but most importantly, financially it is, because that's the root cause. Is it's who pays for this? Mm-hmm. And I think that we all have to pay for this. So there have to be programs in industry. The question I have is, industry may be thinking about this. They may be doing things on their own that we don't know about. That's also the lost chord that we'd like to find is, are they privately working on this? Are there people working on this in the future? Because they'll be future clients once they know that there's kindred spirits thinking along the lines that this is a problem that we have to solve with some dispatch. It's not critical yet, mm-hmm. but it will be.
We're going to be okay until you put into the computer, into AI, how do we take drones apart? And AI responds, we do not take drones apart. Mm-hmm. Then we got a problem.
That's right.
Jim, thank you so much for being on today. Really great conversation.
Well, thank you for having me. And I do want to leave you with a variation on your taglines. Mm-hmm. They say at JAKTOOL, idea to done. Mm-hmm. And this broadcast is idea to do.
Explain.
We have to do it.
Got it.
Idea, it's an idea that we have to do.
Got it.
So I just took off two letters, an N and an E, and switched it up. It's an idea that someone should pick up and run with,
do it.
and try it, because I think it has opportunity.
Idea to do. Yeah.
Thank you very much for your questions. As always, I'm humbled to be interrogated and questioned by you. You bring out the best in me. I mean, it's a compliment.
Thank
you. I always say people interrogate me. They ask me questions, but I play with words. But it's a pleasure to be here, and I'm very proud and humbled, and that you support me as a subject matter expert and a consultant at JAKTOOL. It's been fun, and I appreciate everything. Thank you,
Jim. Thank you. Everyone, thanks for hanging out and listening to us discuss this. Please take a look below in the link. Follow us on LinkedIn and YouTube if you could. Appreciate it. And any comments, please put below. And we're always checking and we will respond. And if there are engineering students out there going into your capstone course and you're looking to discuss this more, reach on out to us. Sounds fun. Thank you very much.